All right, welcome. We're looking over problems from section 6.1. Problem number 1. It asks you to find the area of this shaded region. So remember, in this section, we are really just going to do an integral for number 1, where we go from the leftmost value of 0 to the rightmost value of 4. And we're just going to do the typical approximating rectangle. Looks like so. We have a dx involved there. And pardon the bell, it's the top function, 5x minus x squared, subtract the bottom function, minus x. And then you take that integral and go from there. This one's simple enough, and there's the answer in the back of the book, so we'll leave that as it is. 4 is worth thinking about, though. So 4 is a little bit different, because if I think about a typical approximating rectangle, if I do them vertical like I did before, then sometimes the top hits the blue, sometimes it hits the red, sometimes it hits both. That could actually be very annoying to have that difference. But if I drew them horizontally, the left endpoint is always on the blue shape, and the right endpoint is always on the red. So that tells me this is a better one. So with that, notice that the short side is in the y direction. So we'll call that a dy. Now the y values are going from 0 up to a value of 3 for the y. And we're going to do the leftmost x value, which is y squared minus 4y. Well, excuse me, we should start with the rightmost value. I don't know why I did that. The rightmost value, which is the red, which would be 2y minus y squared, and we subtract off the leftmost x value, which is y squared minus 4y. And then you of course, simplify that a little bit before you go about 6y minus 2y squared dy. And then you take that integral and go from there. For the sake of this example, let's just finish that up. So it'd be 3y squared minus 2/3 y cubed, evaluated at 0 and 3. I'm going to plug the 3 in, I'd have 27, so 3 times 9, minus 2 times 9, so minus 18. And then we subtract off of that, plug in the 0, minus 0. So that gives me overall value of 9. That works out pretty nicely. The next homework problem there is number 5. And this one they want us to sketch the region. You're probably hearing everyone outside. This is what it sounds like in my office. I have the door open, which is unusual for me. If you can't hear, I'm going to turn the gain up for a minute. All right, that's enough of that. All right, here we go. Apologies if you have to adjust your volume now. So decide whether to integrate with respect to x or y. So let's draw it. So for number 5, it's helpful to start just by drawing your axes. So y equals e to the x looks something like this. Your y equals x squared minus 1 looks something like this. So x equals negative 1. So let's see, so when x equals negative 1, this thing's equal to 0. So it's this point right here to this point right here. So we want to find this value. So I'm looking at this and I say, it's going to make a lot of sense to have the vertical rectangles in there, because then the top's always hitting the e to the x, the bottom's always hitting the red. So we're going to do the integral from negative 1 to 1. It's going to be dx because we used vertical rectangles, and it would be the top value e to the x minus x squared plus 1. I want to distribute that, negative 1. Great, so then we just do e to the x minus x cubed over 3 plus x, plug in a 1 and a negative 1, and you get that region area to be e minus a third plus 1 minus e to the negative 1 would be 1 over e. Negative, okay, plus the third, minus 1. So we double those. those together, minus 2/3. Still, we can simplify that ever so much. Plus 4/3. Great. The next problem on this list for 6-1 is gotta do 7, 8, and 11. Let's come over this way. So number 7, same way as sketch it. First thing you gotta do is sketch-a-rooney. Doesn't have to be too perfect. Number 7, x minus 2 squares. That means when x is positive 2, I get a 0, and it looks something like this. And y equals x. Oh, just for the sake of it's a straight line, I'm just going to draw it like so. All right, so this one again, if I put something in here, going up and down is the better for the rectangles, and so it's going to be dx. You know, and you have to find those bounds, of course. We'll do that in a second. Call a to b. When I go up, looks like I'm hitting the function of just x, and then when I go down, I'm hitting the function x minus 2 squared. To find those bounds, you just have to see where these two intersect. So to find a and b, we would just ask ourselves. So the first one is they have the same y value. So setting the y is equal, we have x equals x minus 2 squared. So that happens what? When x is 1. That's one of my values. So 1 equals 1 minus 2 squared. Do I have to factor this one out? Maybe I would have to factor this one out. There might be a better way. Let's just do it. So x equals x squared minus 4x plus 4. So 0 is equal to x squared minus 5x plus 4. Then you factor that, you'd have 2 terms. Multiplying the 4, adding the negative 5. So the other one is 4. So it goes from 1 to 4. And then you integrate that. Not too bad. Not interested in the back of the book. So just, this almost looks like you have to use substitution. It's hard to talk today, but you don't have to do that. In fact, well, if you did, u equals x minus 2, du would just be dx. So you could also just think about it and say, yeah, this whole thing would give me, first one is x squared over 2 minus, and this hunk of junk would be x minus 2 over 3 cube, plug in a 1 and a 4, and go from there. All right. Let's just go ahead and maybe go to the next page to look at the next problem. All right. So there's also asking us to solve 8 and 11. So number 8, let's check it out. So when I sketch number 8, fascinating. It doesn't like me sketching on top of that, so I'm going to sketch it over here. 8 says x squared minus 2 and x plus 4, so something like this is the x plus 4 curve. And then, this one, when x is 0, y is 0, so we have a 0 there. And then it goes under, something like this, okay? It's going to be a vertical rectangle, makes sense here. So you set up your function, find out where those intersect, set them equal, and then put the x plus 4 on top. Subtract off the x squared minus 2x down below. All right, let's set them equal to find the values where they in fact are equal. So to find out these points of intersection, the bounds of our integration, you would, for number 8, just set x squared minus 2x. Set that equal to x plus 4. Bring it all to one side, so x squared minus 3x minus 4 is equal to 0. You could factor that, right? To x minus 4 and x plus 1. Yeah, great, that works. So then we have the values of -1 to positive 4. Integrate it and go from there. For number 11, scooch over this way a little bit. Notice they're giving us in terms of x as a function of y. So that's going to be indicative of what we're going to change here. So let's, again, sketch the picture real fast. My pad turned on me there. All right, what do we got? We have x equals 1 minus y squared. So it looks something like this. And x equals y squared minus 1. Look at something like this. Yeah, so looking at these, I'm going to do some horizontal rectangles. So that's going to be a dy. The y values, where do they intersect? Well, when x is equal to 0, y's are going to be -1 or +1. And they're going to do the 1 minus the other one. Now, if you get these ones backwards, that's okay. You just end up with the negative version of what you want in the end. So 1 minus y squared, subtract off the one on the left, y squared minus 1. And this really just gives me the value from -1 to 1 of 2 minus 2y squared dy. And you could keep it going. So remember, when you integrate with respect to y, y's come instead of x's. Then you're still plugging in those values. Notice these are y and y cubed, so they're odd functions, which make it a little bit easier to calculate when I plug things in. When I plug in a 1, I'm going to have 2 minus 2/3, so it'd be 4/3, minus, when I plug in the -1, I'm going to have -4/3, so plus 4/3 equals 8/3. All right, great. We're doing okay on time, but we're going to run out of time pretty short for these videos. It can only be 15 minutes long, so let's see what we got. 13, sketch those regions, find its area, very similar sorts of questions, right? This one, the answer is in the back of the book, so you can check your calculations, but sketching them, y equals 12 minus x squared, something like this, x squared minus 6, something like this. You're going to find out where those are equal. You set them equal, and you find out, well, that happens when 12 minus x squared is equal to x squared minus 6. So that happens when 9 is equal to x squared. So that would be x is plus or minus 3. So we're going to have minus 3 to positive 3. We're going to do dx because we would use vertical rectangles. And then we would do the top value, which would be 12 minus x squared. Subtract off the bottom value of x squared minus 6. And you can integrate that. After problem 13, the next one on our list is problem 14. So very similar. Let's go ahead and I'm just going to erase what we did here. You can pause the video if you need to go back to that. Number 13. For number 14, you can do that in blue. Good old blue. Same idea. Let's sketch our pictures. Right, x squared looks like this. 4x minus x squared. When x is 0, fascinating. When x is 0, y is still 0, isn't it? So we have this value here. It's facing down. But notice that this function right here has shifted my x value so that the other 0 of this particular one would be when x is equal to 4. So it looks kind of like this. And so we're going to have a shape that looks like so. So the area enclosed is right here. We need to find this other piece, this other bound of our integration. So let's set it up. So we're going to have the integral from 0 to what we need to find. It's going to be 4x minus x squared. Subtract off the bottom x squared dx. To find that, we're going to set these equal. It's when x squared equals 4x minus x squared. Right, so that's when 2x squared is equal to 4x. So that's when x is equal to the value of 2. So 0 to 2, right there, are our bounds of integration. We're at time for this video.